1.2. 1.2 said the gravitational acceleration on the surface of the planet of radius r is g. So talking about the gravitational acceleration, so that means that there is the Newton's law of universal gravitation. You have to know its formula, especially the formula for calculating the gravitational acceleration. So it is there at the back of the paper or in the formula sheet, by the way. The gravitational acceleration at a height of 2r above the surface of the same planet is, okay, we have to calculate the gravitational acceleration when this person or this object is at a height of 2r above the surface of the planet. So this is the scenario. We have a planet here. We have a planet here, which is a planet with a radius of r, right? So this is the center of the planet. This is the center of the planet, and then this is its radius. So its radius is r, right? But they say that this person or this what is it? Let me see. Okay, it can be anybody. It can be a person or it can be an object. Let me say it's a person. So this person is now at a height of 2r above the surface. So this is the surface of the planet here. This is the surface of the planet, but the person is 2r. That means 2 times the radius. So he is 2 times the radius, so this is 2r. So he is 2 times the radius above the surface of the planet. So what is the distance between him and the center of the planet? Remember that according to Newton's law of universal gravitation, everybody in the universe attracts every other body with a force that is directly proportional to the product of the masses by inversely proportional to the square of the distance between their centers. So this person is here at a height of 2r above the surface of the planet, but we have to calculate the distance between him or her and the center of the planet. So it is going to be r plus 2r. That means the distance between the person and the center of the planet is 3r. So it is 3r, right? So to be able to calculate the gravitational acceleration, we're going to utilize the formula, which is the at the back of the paper or in the formula sheet, and it is g, which is the gravitational acceleration, is equal to the constant multiplied by the mass of the person over the distance squared or the radius squared, right? So this is how we calculate it. This formula, have it at the back of the paper or in the formula sheet. But because they wanted the gravitational acceleration of the person, we have to utilize the mass of the person. But if they wanted the gravitational acceleration of the planet, we have to know the mass of the planet, or we have to substitute the mass of the planet. Because they said of the person or of that object, we have to know the mass of that person, right? So this is, well, they said that the gravitational acceleration of the person is g. Okay, so this is the g. This is the g when the person is just above the surface of the planet, not 2r above the surface of the planet. So this is the normal one, right? So now we have to calculate the gravitational acceleration when the person is 2r above the surface of the planet. That means he is 3r away from the center of the planet. So that means it's going to be like the g multiplied, which is the constant multiplied by the mass of the person. It doesn't change. Remember that the mass of the person doesn't change, right? So this is going to be over. Now the radius is no longer r. It is 3r, right? So we're going to be like, okay, we have 3r, then we're going to square that. We have 3r, and then we're going to square it. So when you try to simplify this, we're going to have, well, let me say this is g1. So this is the normal gravitational acceleration when this person is just on the surface of the planet. When the person is just on the surface of the planet, let me actually indicate that. So when the person is on the surface of the planet, this is his acceleration, gravitational acceleration. So his gravitational acceleration is u1 when he is on the surface of the planet. But when he is 2r above the